component form. For two vectors, v1 is a1, a2, and v2 is b1, b2, so these are column vectors, the scalar product or dot product is given by v1 dot v2 is equal to a1, a2 dot b1, b2 is equal to a1 times b1 plus a2 times b2. So we just multiply the two top numbers, multiply the two bottom numbers, and add them together. We're given that vector A is 1, 2, and B is negative 2, 3. We want to calculate A dot B using, in the first instance, the component form. So A dot B would be equal to 1, 2 dot negative 2, 3. So that's 1 times negative 2 plus 2 times 3, which is negative 2 plus 6, giving us 4. We now want to use the polar form, so we need to convert these vectors. So let's start with 1, 2. We know that that's 1 across and 2 up. So the third side of this triangle is the actual vector. So that's 1 and 2. Using Pythagoras, this side is root 5. And the angle here, let's call it theta, would be the inverse tangent of 2 divided by 1, which is 2. Let's just leave it there and not calculate it. It's handy to have it exact. Then we have the vector negative 2, 3. So negative 2, 3 is 2 to the left, and then 3 up. So the third side will be the actual vector. So that's 2 this way, and 3 this way. So this side would be 9 plus 4, root 13. And the angle is this one here. If we work out this one here, that would be the inverse tangent of 3 over 2. Therefore, this angle, the one that we actually want, is 180. Take away the inverse tangent of 3 over 2. So if we look at the two vectors, there's something like this. This one is root 5. This one root 13 in magnitude. And we know the whole of this angle is this expression, and that this angle is this expression. So the angle between them, which I'll just call theta, is 180. Take away the inverse tan of 3 over 2. Take away the inverse tan of 2. So A dot B would be root 5 times root 13 times the cosine of this angle theta, which we know is this expression. And we just need to calculate. So that's root 5 times root 13 multiplied by the cosine of 180, take away the inverse tan of 3 over 2, take away the inverse tan of 2. that gives us 4, the same as this. So in part C, we can say those answers are the same. If A is 3i plus 4j and B is 4i minus 3j, we want to calculate A dot B. So all we have to do is multiply the I components together, so that's 3 times 4, and then we add that to the j components multiplied together, so that's 4 times negative 3, so that's 12 take away 12, which is 0. That angle being 0 tells us the angle between A and B is 90 degrees. Let's just examine why. We know that in general, A dot B is the modulus of A times the modulus of B times the cosine of the angle between the two vectors. Now the cosine of 90 degrees is 0. So if A dot B is 0, with the two vectors both having a non-zero magnitude, then it has to be cos theta, which is 0. And that tells us that theta is 90. This is a really important concept. If C is 2i plus 4j and D is 3i minus 5j, calculate the following. So we want C dot D, multiply the I components, so that's going to be 2 times 3, and multiply the j components, so that's 4 times negative 5. 6 take away 20 gives us negative 14. Now in part B, we want to calculate the angle between C and D. C dot D would be the modulus of C multiplied by the modulus of D times the cosine of the angle between. So cos theta would be C dot D divided by mod C mod D. So cos theta is going to be negative 14 divided by the square root of 2 squared plus 4 squared, so that's 16 plus 4, which is 20. 3 squared is 9, 5 squared is 25, so that's root 34. So we just need to calculate the angle. We want the inverse cosine of negative 14 divided by the square root of 20 multiplied by the square root of 34. And that gives us 122.5 degrees to 1 decimal place. So we can say that theta is 122.5 degrees, correct to 1 decimal place. If we were after the acute angle, which is often what's asked, we just take this away from 180. We're now in a position to do exercise 4.02 on page 121.